Okay, part C. Find the coordinates of the point where the tangent to the curve at 0c crosses the x-axis. First of all, 0c is the point 0,3 because we worked out the value for c in part A. We're dealing with a tangent. A tangent is a line. So therefore, the very first thing I should do with the tangent is work out its equation. And in order to get the equation of the tangent, I need a point on the tangent, which I have, 0,3. I need the slope of the tangent at this point, which we'll talk about in a moment. And I need the formula from the tables for the equation of a line, which is y minus y1 equals m times x minus x1. The only thing I'm missing is the slope. The slope of what? The slope of the tangent at this point. Please remember that when you're given a function, the slope of the tangent, the general form of the slope of the tangent, is the first derivative of the function. So if f of x, in this case here, is e to the power of x plus 2, then f dash of x, which is the first derivative, is e to the x. Because the tables tell us when you differentiate e to the x, it stays the same. When you differentiate a constant, it goes to 0. So this thing represents the value of the slope of the tangent at all points. So it's totally dependent on x. We want to work out what is the value of the slope when x is 0. So, at x equal to 0, that becomes e to the 0, which is 1. So therefore I have the slope, I have a point, I have a formula, fill it in. This is x1, this is y1. So it becomes y minus 3 is equal to 1 times x, which is x. Now, the last thing I have to do is to figure out what is the coordinates of the point where the tangent of the curve at 0c crosses the x-axis. And this is the key thing, because another word for the x-axis is y equals 0. So therefore, if I remember that the x-axis has another name, y equals 0, I simply set this y value here to 0, and that gives me 0 minus 3 equals x, minus 3 equals x, which means the point I'm looking for is minus 3, 0.